Sources of electricity and energy. Thermo-electric generating plants. So fuel, such as oil, natural gas, and coal are used to produce approximately 25% of Canada's electrical energy. They are burned and then they produce heat. This heat boils water, which turns into steam. And steam is directed through piping to turn a turbine. Okay. This turbine turns the rotor in a generator, and the generator produces electricity. Fuel sources, again, coal, oil, and natural gas. These are all non-renewable resources, so eventually they will not be available for use. One other is that we also look at biomass. So material from living things, it is more of a renewable resource that we talk about at the end of this presentation. So we can see here we have some sort of coal. We burn it. It heats a tank of water. The water is directed down into piping and turns a steam turbine. The turbine turns the rotor in a generator, and that produces electrical energy. The steam, as it's gone through the turbine and turned the turbine, comes out, condenses or cools back down into more water, and can be fed right back into our combustion chamber. So we can keep recycling the water at least, but not the coal. Thermo-electric generating stations and the environment. So burning fossil fuels obviously releases greenhouse gases, mostly carbon dioxide, sulfur, and nitrogen dioxides. We can use scrubbers to reduce some of the SO2 and NO2 emissions, but we cannot reduce really that carbon dioxide piece. One thing to note, for every 1 ton of carbon or coal burned, we make 3 tons of CO2. All right, approximately. So the amount of CO2 that we put into this atmosphere in burning fossil fuels is quite large. Again, acid rain comes from these gases, so carbon dioxide, sulfur dioxide, and nitrogen dioxides. It also creates thermal pollution. So it generates heat that isn't turned into electricity and heats up the environment, which isn't great. There's open pit mining that's used to source some of these fuels. You can see an open pit mine over here. It's got tracks all the way around so that equipment could get down there to mine the coal or whatever they were looking for. It really disturbs, obviously, the soil, vegetation, and the ecosystem in this area. Underground mining produces tailing ponds or waste materials that can contaminate the groundwater. So often they are held in a pond, and more often now, of course, they are lined ponds so that they don't disrupt our ecosystem. However, birds can still land in them, etc. So they are not completely contained from an ecosystem, even if they are lined. There's a video linked below. There's a ton of videos actually linked below. One for almost every type of electricity generation. Hydroelectric. So we use falling water or gravity and the pressure of that water to produce electricity. So large dams raise the water above the power plant. So when they build a dam, they do so to make the water up higher. Okay, so that will flood some areas. But once we've done that, we can use the pressure and gravity of water coming through a penstock. It directs this water at a high pressure towards a turbine. Water turns this turbine, which turns the rotor in our generator, producing electricity, and the water continues downstream. Again, I kind of mentioned a dam creates environmental damage, the flooding of this area. This wouldn't have necessarily been flooded to begin with. It can displace people and animals when that flooding occurs. And the vegetation or plants that were there before decay and produce methane gas and algal blooms. This can produce some blocked waterways. Some dams, however, are built right into a waterfall. And that can be a little bit more environmentally friendly because there was already falling water to begin with. Nuclear power. Nuclear power comes from nuclear fission. So, bombarding uranium atoms with neutrons causes uranium to split into two smaller atoms. So, a neutron comes and uranium splits into two new atoms. When it splits, it releases energy. It also releases more neutrons that can hit other products, which then break down again, releasing more energy, and it just creates a chain reaction. When this energy is released, it produces heat. This heat is again used to turn water into steam. Steam turns a turbine, the turbine turns the rotor, and a generator produces electricity. You can see that we're just using different methods to turn a turbine, to turn a rotor in a generator. All right, here we go. We have our reactor vessel. This is where our uranium is and where it's breaking down into other things, creating heat. So when it is heated, we get water around it heating up. It heats up and creates and turns this water around it into steam. This steam is generated and turned towards a turbine, which creates electricity. And again, we're going to cool the steam back down and recirculate it back into our watering system. Nuclear power plants, the waste can last hundreds of thousands of years. So when we build them, we need to be able to account for the waste that the nuclear byproducts will generate. So where do we dispose of or store radioactive waste? Who wants to be near that? Again, thermal pollution, so creates quite a bit of heat. And the risk for an accident, although lots of safety precautions are in place, there are instances where we can think of a nuclear meltdown. So Chernobyl here. And so their reaction got out of control. They couldn't control it and it burst out of the reaction chamber, and that amount of energy, they couldn't slow that reaction. It just continued to produce energy and destroy the building. In Fukushima, in Japan, there was a tsunami. So an earthquake created a tsunami. The tsunami wreaked havoc on their nuclear power plant, and they ended up having a meltdown and a release of radioactive material as well. So all thermonuclear and thermoelectric generating plants release thermal energy into the environment. We've seen that here. So thermal pollution occurs when this heated water is not cooled before it re-enters the water system, and this can affect plant and animal life. So this was from maybe our coal, natural gas, and oil generation, but we also have this in nuclear power generation. So, other forms of energy. Cogeneration systems are stations that produce electricity that can also produce heat. So they use this excess thermal heat to heat water for the buildings of surrounding industries or towns. It reduces this waste energy because we are using this heated water for something. It reduces that thermal pollution and even makes extra energy for provincial power grids. Other forms are wind energy. So they produce electricity from wind power, turning a wind turbine. Southwest Alberta has lots of wind, so large wind farms have been used to create electricity there. They don't create any pollution or chemicals, and this is a renewable energy source. However, it cannot be stored, so any power that's generated by a wind energy station is directly put into the grid. However, if energy isn't being used or needed in the grid, it is wasteful. However, if we start sharing between provinces, perhaps we don't really use a lot of hydroelectric. Maybe we could switch with BC for some of our wind energy. That's a thought that has crossed some people's minds. Although they don't create any pollution, a lot of people think of these as an eyesore, and they do kind of kill birds and wildlife that are flying because of the wind turbine turning. Solar energy, so heat from the sun, is used for thermoelectric generators. So we can use the heat from the sun to just generate heat energy. But we can also use photovoltaic cells. So electricity can be produced. There's no pollution and it's renewable, but it's not always available to places with little sunlight. And it's quite expensive to install, even if the price has gone down recently. All right, or tidal or ocean energy. So massive water movements, like the changing of the tides, can be harnessed to spin turbines. So when water comes in, it is trapped in large reservoirs and then allowed to flow out past these turbines here. Only a few places, like the Bay of Fundy in Nova Scotia, I actually think that's New Brunswick, have tides that are strong enough to generate this kind of power. So it takes a special area. Not every place along the coast could do this because we need to have the large reservoirs of water that get created by the tides. It can disrupt habitat or of the marine life. And there is concern that perhaps the noise even from this disrupts some of the sonar signals that maybe whales and dolphins and other aquatic animals use to communicate. Geothermal energy. Heat energy from under the earth is used to heat our homes, but also to create electricity. So this heat and steam can be used to turn turbines again for electricity and for heating water in homes. It is pollution-free and renewable, but only a few places have energy like this available. So in Iceland, there's a little bit of this in Okotoks, the Banff Hot Springs. Really what we're looking at is groundwater that is quite warm because it is being heated by Earth's crust. And we're using that to generate steam to turn a turbine in a generator to create power. But in some cases, this hot water is directly used within homes to heat the home just with hot water, not with electricity. Biomass. I kind of briefly touched on this when we were talking about fossil fuels. So burning of biomass rather than fossil fuels. Biomass is a fuel produced from biodegradable wastes. So as our composts perhaps decompose, the gases are collected and then used as a fuel for steam-driven generators. Some sources of biomass are grass clippings, dead trees, food scraps, peelings, etc., etc. Alberta has 9 biomass stations, is what I am told. So how does Alberta stack up? This is a little pie chart for our total electric generation in 2018 as a province. So you can see here that 49%, almost half, of our electricity is generated using natural gas. So we burn the natural gas, creating steam that turns turbines. Coal amounts to another 43%. So pretty much the other half of our electricity generation is from coal. Coal is less environmentally friendly than natural gas because coal contains many more imperfections and therefore creates more harmful gases. Wind energy is about 6% of Alberta's total electric generation. Hydro is 3%. We don't use a lot of hydro, whereas if you looked at BC would have a very different graph here. Biomass is about 3%. Petroleum, so different petroleum products other than natural gas and coal. And then solar is less than 0.1 as well. Take a look at the learning guide for this topic. There's some extra practice on page 342, number 1, 2, 3, and 4.